All right, this is the second video on 5.3. So again, this number 12. So compute eigenvalues and eigenvectors for this matrix A. So again, remember that A V equal to lambda V, right? So V L lambda is just a number and V is a vector. So first you're going to write down A minus lambda I times V equal to 0. So I'm going to find the determinant of this one to find the eigenvalues. Okay, so if you set up like that, so this is your A minus lambda I is that. So if you subtract this one, you're going to see like and this number minus lambda, which is that, and this one minus lambda, that's what, and then rest is all going to be same, right? And then you do that finding the determinant, and then you're going to see that lambda equal to 1. So here's like we have a repeated root, right? So the lambda is both 1 1. All right, so when lambda equal to 1, so that's your eigenvalue. So you just plug in back here into lambda equal to 1. So just put like that, lambda equal to 1. And then this is your V, and then is equal to 0, right? So that's the equation. And then change this one into like first just write down, just copy this right there. And then now this is already in a row reduced echelon form, right? So that means I can write down the equation. So this is like a 0, you don't even need this one. So V2 equal to 0. V2 has to be 0. So so your free variable is a V1, because look at that, I don't have a pivot first. I don't have a pivot column in the first, right? So V1 is a free variable here. So I'm going to write down V1 equal to V1, and then V2 should be equal to 0. So that's why it's 1 0, right? So lambda, when lambda equal to 1, you have only one eigenvector, which is 1 0. Okay, but just a note, when there's a repeated eigenvalue, does not always get only one vector. So you might get two vectors, which you can find this one in example number 5 in your book. All right, but I think there is one example for you guys to hear. All right, let's look at another example. Look at this. A is 1 1 3 3, right? So this is like a linearly dependent column, isn't it? So let's see again. Write down A minus lambda I. So it's going to look like this. Find the determinant of this one. Just to find the eigenvalues, find the determinant of this matrix. So do that, and then you can simplify that, and then look at here, and you're going to figure out 0 and 4 are the eigenvalues. Okay. Now let's see. When eigenvalue is 0, again, A minus, this one is a minus lambda I, V equal to 0. So you're trying to find the kernel of this matrix, isn't it? Kernel of this one. Again, change into row echelon form. That's your row echelon form. So reduce row echelon form. And then change right down in the equation. So V1, 3 V2 equal to 0. So that means V1 is negative 3 V2. So V2 is your free variable, right? So V2 is free variable. Free variable means that's not a pivot column, doesn't have a pivot column, right? Free variable. So that means V2. So just write down V1, V2 first, this component of the eigenvector. And V2 is like because free variable, you just write down here. And then negative 3, because V1 has to be equal to negative 3 V2. Look at that, that's your V1. And V2 has to be 1. V2 equal to V2, right? That's why now this is eigenvector. Okay. When lambda is 4, what is my eigenvector? So when eigenvalue is 4, what is my eigenvector? Again, put it back here into this matrix for lambda equal to 4. So I get this matrix, V1, V2, Just write down that vector in component wise and 0, 0. Now I'm going to, again, pause this one video and change into reduce row echelon form, reduce row echelon form. So I got this one. Now again, so this, if I write down in an equation, V1 minus V2, V1 minus V2 equal to 0. So that means V1 equal to V2. Okay. Again, V2 is a free variable. Free variable. So again, V2, just write down that. And it has to be 1 here because V2 equal to V2, right? You cannot have 0 there, right? And then V1 and V2 are same, so that's why it's a 1 here too. So it's a 1, 1. So eigenvector is 1, 1. All right, so again, when lambda is 4, your eigenvector is 1, 1. When lambda is 0, eigenvector is negative 3, 1. Okay. All right, let me do another video. I'll stop here.